This is question number 25 from workbook. It says ABC are in GP, and we have to prove this relation between the LHS and RHS. So what we can do that we know that the first three terms of an AP is A, AR, and AR square, and A being A, the second term is B, and the third B, C. So that means if needed, we will replace A with A only, but B with AR and C with AR square. So that we'll do in the LHS and RHS part. So let's say first if I write LHS, this is A plus B plus C, the whole square, that divided by A square plus B square plus C square. Now let's replace A being A, B, right? B is from here, right? B can be written as AR square, so I'm writing B as AR, and C being AR square, right? From here. Now, so we will do in the denominator also. The denominator A square is A square only. B square can be written as A square R square, and C square is A square R raised to the power 4. Now, as you can see, we are getting something common here. A being common from the numerator, but if it comes out, the bracket, it will become A square. So this is A square. If I take common, I'll get 1 plus R square, that raised to the power, whole raised to the power 2. And I can see A square is common from the denominator. So this should be written as 1 plus R square plus R raised to the power 4. Now what we can do is to factorize it further. That we need some space. So you see that A square and A square get cancelled, right? So now we can factorize this further. I can keep the numerator as it is, raised to the power 2. Denominator I'm factorizing. I'm writing 1 as 1 square. I'm writing 1 as 1 square. I'm writing this as 2r square minus r square plus r raised to the power 4, which is like this. I did nothing. I split r square as 2r square minus r square in order to factorize it. I'll do the remaining part on the other side of the screen. So once again, continuing with the numerator, the LHS being same, the RHS, clubbing these together, right? Taking this as A square, this being B square, and this being 2AB, right? I can write this as A plus B whole square. That means A plus R square, the whole square, and minus R square can be written as minus R whole square. So that was a factorization in order to reduce, as denominator can be split in a factors of the numerator. That's what I'm doing this. Now further, I'll be applying this identity called A square minus B square. That is A plus B into A minus B. A plus, this is A plus B. And then we have A minus B, that is A is this minus this. As you can see here that this whole quantity will be cancelled with this. They are same, right? 1 plus R square, irrespective of the order. So now we are left with 1 plus R square in the numerator and 1 minus R plus R square in the denominator. So that is what we got, the LHS. Now we need some space to do the RHS. This is the LHS part. Now I'm writing the RHS here. The RHS is, it says A plus B plus C over A minus B plus C. Same thing we are going to do here. We are going to replace B with AR and C with AR square, A being A only. So A being A, B being AR, and C being AR square. Denominator same here. This is plus, sorry. This is minus. AR plus AR square. So I can take A common here. So it will give you 1 plus R square. And in the denominator, if I take A as common, 1 minus R plus R square. So this get cancelled. As you can see now, this and this are same, right? The LHS is same as the RHS. Hence it is verified.